Now let us solve few examples based on the formula for angle between two lines. Find acute angle between the lines having direction ratios 3, 2, 6 and -2, 1, 2. Okay. So here, since we are given direction ratios, that means they are in symbols A1, B1, C1 and A2, B2, C2. Correct. We know the formula for cos theta, which is given by mod of A1, A2 plus B1, B2 plus C1, C2 whole divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square, right? So we put in the values, so therefore we have 3 into -2 plus 2 into 1 plus 6 into 2 divided by 3 square is 9, 2 square is 4 plus 36 into we have 4 plus 1 plus 4, so that equals, here we have -6 plus 2 plus 12 divided by root of 49 into root of 9. So therefore that is further equal to 8 divided by 7 into 3, which turns out to be 8 upon 21. So the value of cos theta is 8 upon 21. So therefore we write the final answer theta as nothing but cos inverse of 8 upon 21. So that's the angle between the two given lines, right? Let's go ahead to the next sum. Find direction cosines of the vector which is perpendicular to the vectors having direction ratios as -1, 2, 2 and 0, 2, 1. So now here, if we consider two vectors, say a bar and b bar, then let us ask the question, which is that direction which is perpendicular to both of these vectors? And we know that clearly it is the vector in the direction of their cross product, because if you remember or recollect the cross product, that vector is perpendicular to both of the vectors a bar and b bar, correct? So that means first we have to calculate the cross product, and once we get the cross product, that is a vector in the required direction, we can easily find out what are the direction cosines of that particular vector, correct? So therefore let us first calculate the cross product of a bar and b bar. So a bar cross b bar is given by the determinant I, j, k. Coefficients of a are -1, 2, 2 and coefficient of b are 0 to 1. So this turns out to be, now in case of I, we have the coefficient as 2 minus 4 times I cap minus -1 minus 0 times j cap plus -2 minus 0 k cap. So which is nothing but -2 I cap plus j cap minus 2 k cap. So since this is the vector in the required direction, its ijk coefficients, which are -2, 1 and -2, they are nothing but the direction ratios of that particular direction. But we have been asked the direction cosines to be found out, correct? And we know the direction ratios. So how to find that? We know that we have to calculate the quantity lambda, which is 1 upon root of -2 the whole square, which is 4, plus 1 the whole square, which is 1, and once again -2 the whole square, which is 4. So that turns out to be 1 upon root 9, and hence lambda is equal to plus or minus 1 by 3. Correct? So now we know that L is equal to a lambda. So therefore here we get L is equal to plus or minus -2 upon 3, then M is equal to b lambda that is equal to plus or minus 1 upon 3, and n is equal to c lambda, which is equal to plus or minus 2 upon 3. So therefore we get the two sets, as the first set is, if you consider the plus sign, we will get minus 2 by 3, then 1 by 3, and minus 2 by 3. This is the first set. Or the second set is by taking the negatives of all the values, so which are nothing but 2 by 3, minus 1 by 3, and lastly 2 by 3. So therefore these are the direction cosines of the required line. Basically we get two pairs, the two opposite values, because they indicate two opposite directions of the same line. Let's go ahead to another important type of question. Now here, if M is the foot of perpendicular from point A, whose coordinates are 4, 3, 2, to a line joining points B and C, whose coordinates are given, then find the coordinates of point M. Right, now here let us show it by a small figure. That is, we know the coordinates of point A, and from that point A we are drawing a perpendicular with foot as M to the line joining points B and C, and whose coordinates also we know, that is 2, 4, 1 and 4, 5, 3, and we have to find the coordinates of point M. Right, now here if we assume once again coordinates of point M for the time being as say x, y and z, okay, we know that the direction ratios of line joining points B and C, they will be the respective subtraction. So 4 minus 2 is 2, 5 minus 4 is 1, and 3 minus 1 is 2. Correct. So therefore we have the direction ratios as 2, 1 and 2. But we can also calculate the direction ratios considering the points B and M, because they also lie on the same line. So the direction ratios can be written as x minus 2, y minus 4 and z minus 1. And since both the sets refer to the same line, they must be in proportion. So therefore we can write x minus 2 upon 2 must be equal to y minus 4 upon 1, and that in turn must be equal to z minus 1 upon 2. And let's call this common ratio as lambda. So that gives us x is equal to 2 lambda plus 2, y is equal to lambda plus 4, and z is equal to 2 lambda plus 1. Correct. So these are the coordinates of point M. Now we have to use the condition of perpendicularity, and we have seen that the two lines are perpendicular if a particular condition in their direction ratios or cosines is met. Right? Now BC direction cosines and ratios are known, and the direction ratios of AM also can be now found out, because we now know the coordinates of point A and point M. Okay. So therefore let us write here direction ratios of AM are. Now here what we'll do is we will merely subtract the coordinates, that is 2 lambda plus 2 minus 4. Correct. So they are 2 lambda plus 2 minus 4, that is 2 lambda minus 2. Then from lambda plus 4 we will subtract 3, so that turns out to be lambda plus 1. And lastly we have 2 lambda plus 1 minus 2, so therefore that turns out to be 2 lambda minus 1. Okay, so these are the direction ratios of AM, and the direction ratios of BC are already known. They are 2, 1 and 2. Now since the two lines are perpendicular, when we do the cross corresponding products of direction ratios, their addition must be 0 as per the condition for perpendicularity, correct? So therefore we have 2 into 2 lambda minus 2 plus 1 into lambda plus 1, so therefore that is nothing but lambda plus 1, and lastly plus 2 into 2 lambda minus 1. Equal to 0. So therefore when we solve this equation, that will give us the value of lambda, right? And once we get the value of lambda, we will substitute that in these particular formulae. So therefore that will give us the coordinates of point M, which is the required answer, which is the foot of perpendicular, right? So this is the procedure to calculate the coordinates of foot of perpendicular such that the perpendicular is drawn from any point outside the given line.